Okay, this is AS Statistics. We are just starting Unit 3 and we're taking a wee look now at bivariate data. So I'm just going to read through this and try and get our head around what we're talking about. So scatter diagrams and correlation coefficients. Bivariate analysis is the analysis of two sets of data in order to see if there's a link between them. This link is called the correlation. At GCSE we drew scatter diagrams and then drew a line of best fit by eye, as in just your best line of best fit, to see if there was a correlation between the two variables. At GCSE further maths we found out if there was a correlation using Spearman's rank correlation coefficient. The calculation of a correlation coefficient gives you a more reliable result than the by eye method. However, there are advantages of plotting a scatter diagram. These include the scatter diagram allows you to spot any obvious outliers which may affect the results of your calculation. You can get some idea of the degree of the correlation and whether it's positive or negative from the scatter diagram, which might allow you to spot if you've made an error in your spreadsheet calculation, such as selecting the wrong set of data. And you can see any other features of the data. For example, the points might form two distinct groups. If you're in my Year 9 class, I normally put these three up on the board. So these three scatter diagrams. This is just a wee reminder about how a scatter diagram works. And what I tell people is that during 1 year I worked in the park and I sold three things. I sold ice cream, I sold crisps, and I sold hot chocolate. And what I did three graphs showing the amount that I sold of each and the temperature that particular day. So I told people I worked for 60 days. So in each of these there should be then kind of 60 wee crosses. Obviously there's not, but it's just to give the idea. And they then have to match each one. So this is just showing very, very straightforward. This is Year 9 stuff really. So this one here, as the temperature goes up, I sold more. Can you see that there? So that must be the ice cream, because on the hotter days then I sold a lot more. For this one here, as the temperature goes hotter and hotter and hotter, I sell fewer and fewer and fewer. So that must be the hot chocolate one going this way. That's a negative correlation. And then this here is the crisps one. There's no correlation really, or no pattern here between the amount sold and the temperature, because crisps taste fantastic no matter what the temperature. So those are the three. That's a positive correlation, that's a negative correlation, and that then is no correlation. So this one heads towards 1 if you get it even straighter than this, and you know, almost not quite in line, but every one kind of goes up from every previous one. That would give you a correlation coefficient of 1. From here this is going to be quite close to 0, and then this gets closer then to -1. And you maybe remember that last year then from doing Spearman's rank correlation coefficient. So we're moving on to another one today. So there's another way to find out if there's a correlation. This is by calculating the product moment correlation coefficient. A correlation coefficient has a value between -1 and 1 and gives a measure of how good the correlation is. A correlation coefficient of 0 means there's no correlation. A correlation coefficient of 1 means there's a perfect positive correlation, and so the data lie in a straight line with positive gradient. Correlation coefficient of -1 means that there's a perfect negative correlation, and so the data lie in a straight line with a negative gradient.